Hello guys, my name is Aditya. In this session we'll talk about graphs. In graphs we'll talk about DFA. So what is DFA? DFA is nothing but it is a traversal. In BST we have pre-order, in-order and post-order. Similarly in graphs we have DFA and BFA. We'll do it by taking two examples. So in first example there are 5 nodes given and they are connected as shown here. So this is a graph. So we'll write adjacency list for the following graph. So what is adjacency list? So if we see here for 0 from 0 we have root 2, 1 and 2, right? So for 0 we'll write 1, 2. So this is a list. So from 0 to what all we have, we'll write it in a list, and for 0 that will become the adjacency list. Similarly for 1 we have root 2, 4. So we'll write for 1, 4. Similarly for 2 we have root 2, 1 and 4. So for 3 we have root 2, 0, 2, 4. For 4 we don't have root 2 anything, so it is a null, so we don't have anything. Similarly in second example, this consists of 4 nodes. So for this, from 0 we have 2, 1 and 2. From 1 we have 2, 2 and 3. For 2 we don't have anything. For 3, 2, 0. For 3 we have 2, 0 and 2. So this is the adjacency list. So now we will see what is DFA, traversal. So we'll start from 0. Okay, from 0 the first element in its adjacency list is 1, so we'll jump to 1. Okay, we'll jump to 1. So what is the first element in 1's adjacency list? It is 4, so we'll write 4. So till here, okay, so we came to 4. So for 4 we don't have anything in its adjacency list. So what we'll do, so we came up till here. So from 4 we'll go back to 1. So 1. So for 1 again we have 4. So 4 is already visited, so no need to write again. So again we'll come to 1, 0. Yours. For 0, 1 is visited. We have another number 2. So we'll write from 0 to 2. Sorry. So till here it's fine, but we have one more node which is not visited, that is 3. So what we'll do is we'll write separately 3, and from 3 we have to 0, so we'll write in this manner. So this is the DFA of this particular graph. And in compiler how we'll print is, see, like this: 0, 1, 4, then 2, then 3. This is how we will print. Similarly for this particular graph, for 0 to 1 we'll go to 1 and to 2. Then for 2 we don't have anything, so we'll come back to 1. 2 is already visited, then we'll go to 3. This is your DFA for this graph, and the series it will get printed like this: 0, 1, 2, then 3. So this is how we'll do. So what we observed is, once the node is visited, we will not rewrite again. So once it is visited, we should keep a boolean variable in our program such that it will say that it is visited. So that is important. And second thing is, if in this adjacency list, if I write 2 and 1 instead of 1 and 2, it is changed. So it is totally different actually. So uh, we should keep that in mind. Okay guys, now we got to know how this DFA works. Now we'll try to code it. So before coding it, let's think about what all classes it requires. So first thing is it will require a main class or a driver class, it's obvious. And second thing is a node class, because this is a node, right? These all are nodes actually. So this is a node, and this node consists its name, its label, and it consists of its adjacency list. So in this particular node class, we'll have control over its label and its adjacency list. So we'll require a node class. Then we'll require a graph class. What is this graph class? So we have this graph class contains the array of all these nodes. So we'll have control over all the nodes. So for that control will require graph class. So we'll see how the code works. I'll show you how the code works. Okay, so guys, I have said that we'll require three classes, right? Node class, graph class, and main class. So in the node class, we'll have a label for that node, its name. And second one is array list. Array list is its adjacency list actually. Its adjacency list means if 0 is there, its adjacency list is 1 and 2. So these both are also node. So array list will be of type node, and this list is its name. So node, this is a constructor. So node of int l. So if we will pass an integer, and that will become its label, and for that node an adjacency list will be instantiated. It will be empty first. So if we'll declare something like if we'll create an object of type node, if we'll do this, a node 0 will be created, its label is 0, and it will have an empty array list. It will have an empty array list, but it does not contain any elements. Its array list does not contain any elements. So this is the node class, and this is the graph class. In the graph class, as I said, graph class contains array of all the nodes. So this is node, and so array of nodes, and its name is node. The array name is nodes, and in size this will store the size of that number of nodes of that array. Okay, so this is the constructor will pass the size of the number of nodes it has. So we'll pass number of nodes in this it has. So this integer will take that n value. Next this what it will do is it will create, we have declared the array, but we have not mentioned the size of the array. So what it will do is it will create instantiate an array of size n, and what it will do is it will create the nodes. So if we will do for int I is equal to 0 less than, it will create a number of nodes. So if we'll pass, so if we'll do like this, graph a is equal to new graph 4. So what it will do is it will create 4 nodes, and it will create an array of size 4, and it will create 4 nodes 0, 1, 2 and 3. and it will create this. The array contains these elements, and each array, as we know, if we'll do node of 0, it means it will have its label, and it will also have its array list, but the array list is empty now. So guys, these are the three classes: node class, graph class, and driver class. So in the graph class, we pre-assume that we have two methods, print and add adjacency list. This add adjacency list will take integer and array list as argument, and add adjacency list to the particular node, and this print method will print the elements in this manner: 0, 1, 2, like it will print the elements. So if we do DFS for this following graph, we'll what we'll do is 0, then we'll jump to adjacency list of 0, which is 1. We'll go to 1, and we'll go to 2 doesn't contain anything, so we'll come back to 1. So we'll check if if any of the first element is visited or not. So we have to keep in mind that if it is not visited only, we have to go and print the next element. So what we'll do is we'll create a boolean variable in node class. When we declare itself the as boolean, as it is a boolean, the visited will be false when we declare it. So in the graph class, I have created a method called DFS. So for I int I is equal to 0 less than n I plus plus, so what it will do is from 0, as the array contains 0, 1, 2, 3, from 0 to these all things, it will go on do the DFS method. So when we'll do it, when it is not visited, that time we'll do it. So if not of nodes of I dot visited, so it means that if node is not visited, then what we'll do is what it means is, if the node is not visited, then go to node class and check for a method called DFS and do what it does. What that method does, you do it. So what we have to do here, so if we'll start with it, we'll first element is 0, okay. So 0 is not visited yet, so we'll do 0 dot DFS. So it will come here, right? As 0 is a node, it will come here. So what it will do, first what we should do, we should print the label of it, right? 0 we are printing, see, 0 we are printing means we have to print the label of it. So what we'll do is system dot out dot print this dot label, okay. So it will print the label 0. Then what it will do is, again it will check its adjacency list. If its adjacency list is not visited, then what we'll do is, so first we'll write for int I is equal to 0, I less than adjacency list dot size I plus plus. So one thing is, if we'll print it, we have to make it's visited as true. So what we'll do is visited is equal to true. So here what we'll do is we'll do what this for loop does is it will check if its adjacency list elements is not visited. If it is not visited, then it will recursively call this DFS method. So what we'll do is if list dot get of j dot if not of, so if it is not visited, what we will do, we'll do DFS of this list dot get of j dot DFS. So what this list dot get j means, list dot get j, so it will 0. If we'll do here, it will go to 1. It will, so 1 is not visited, so it will go with 1 it will do DFS. So it will do get of j means it will get that node, so 1 dot DFS it will do. So 1 gets printed, and once visited it will become true. Then it will go to 1's adjacency list and it will see 2 and 3. So it will go to 2. 2 is not visited, so it will what it will do, it will do 2 dot DFS. Again it will come here, 2 will get printed and it will become true. So again it will go here, and for 2 nothing is there, so what it will do is it will go here again. So again it will go here. So for int I is equal to 0, 0 is done. Again for 1, what it will do is 1 is visited, so it will not go here. It will come to 2, 2 is done, so 2 is not will not come here. And then 3, so 3 will get printed. So guys, I have shown you the DFS traversal on paper, and in computer the code looks like this, and it contains as I said, it will contains 3 classes: node class, graph class, and driver class. Node class, it will contain label and list, and as I said, it is a constructor. And this is a in graph class, it contains arrays of nodes and the size, and this is a constructor. Then this is the, as I said, this will add the adjacency list for that element. So it will take the argument number like 0. So and for 0 the adjacency list is 1 and 2. Then the list containing 1 and 2 will get passed in this. So then list get added to that particular node. And this print method works like DFS itself. Will print the I, and will invoke the method in node class, the print method using each node, and it will get printed. So first we'll print the, what we'll do is for each array element, it prints the, if array contains 0 1 2 3, it will print 0, and it will go to that node class, and it will print its adjacency list. Then it will come back, and what it will do is again 1, it will print 1, and 1 for 1 its adjacency list, it will go to here and it will print its adjacency list. Similarly, it will do, this print method will do that work. So as I said, DFS, so this is the DFS. as I said, for if it contains 0 1 2 3, I have set this on paper, and this is the code, how it will look like. And see, and if we go to driver class, see, I have created object of graph type graph, and its size is 4, and I have declared array list. See, first array list, this array list, in this array list I have added 1 and 2, and this array and in second array list I have added 2 and 3, and in third array list I have added 0 and 2. And what I have done is I have created so what I did is I have invoked this method add adjacency list. For 0 I added this list A, which contains 1 and 2. For 1 I added the adjacency list B, which contains 2 and 3. And for 3 I have added adjacency list containing 0 and 2, and for 2 nothing I added, so it will remain empty. So this print method, it will print the elements, and this is the DFS. So if we'll run the code, see, 0 1 2 and 3, and this is the print method, and this is our DFS. So that's it. Thank you.